Welcome to part 2 of 2.3 using principles together. So we're going to still be solving these equations, so we're trying to isolate the variable. Now, if we look at this first one right here, we notice that there's a lot of fractions going on. And you could move the fractions around and isolate the t, but I find the easier thing to do here is multiplied by the lowest common denominator. So notice in denominators we have 3 and 4. The lowest common denominator between those two things, which is also known as the least common multiple, is 12. So if we multiply everything here by 12, you'll notice what we get is this. So we'll have 12 times 2/3 plus 12 times 1/4 t equals 12 times 1/3. Now what ends up happening here is because we're multiplying through by the lowest common denominator, this 3 cancels the 3 and the 12, leaving me with a 4. This 4 cancels with the 4 and the 12, leaving me with a 3. And then this 3 cancels with the 3 and the 12, leaving me with a 4. So all our denominators are essentially 1 now, and we can multiply through like we would. Now here we have 4 times 2, that's going to be 8. Here we have 3 times 1 times t, which is just 3t. And over here we have 4 times 1, which is 4. Now, once we have it here, it's much easier to manipulate this and solve it like we normally would. So we want to get the 8 to the left side, or the right side, so subtracting 8 from both sides. Those cancel, so we get 3t equals 4 minus 8 is negative 4. And then finally dividing by 3 here. We get cancellation here, and we get our answer, t equals negative 4/3. We can always, of course, plug that back into the original equation to make sure that it is, in fact, is the answer that we want. I'm not going to do it for the sake right here, but we can always do that. So moving on to this next one, you'll notice that we also have a lot of fractions. So when we look for the lowest common denominator, we have 3, 12, 4, and 4. So the lowest common denominator is going to be 12. And so really what we're doing is we're multiplying each of these things individually by 12. So if we look at that, I'm going to go ahead and do that up here. Give us a little more space. So if we have 12 times 5/3 plus 12 times 2/3 x equals 12 times 25/12 plus 12 times 5/4 x plus 12 times 3/4. We'll notice that once again, all the denominators cancel out. So here, 3 goes into 12 4 times, leaving us with the 1 down here. So we multiply, we have our 4 times 5, which is 20. So I'll write that down there. Get a little space. 3 goes into 12 4 times, so we have 4 times 2x, so that's plus 8x. 12 goes into 12 1 time, so 1 times 25, that equals 25. Here, 4 goes into 12 3 times, so here 3 times 5 times x is plus 15x. And then finally 4 goes into 12 3 times, 3 times our 3 is plus 9. So now that we've gotten rid of all of the denominators here in the fractions, we can go ahead and simplify by combining like terms on an individual side. So on the left side, there's nothing to combine. We still have our 20 plus 8x equals 25 and 9 is going to give us 34 plus 15x. Now we have to move our x's to one side and our numbers to the other. So I'm going to move my x's to the right, so subtract 8x from both sides, and then subtract 34 from both sides to get the numbers over to the left. So we're getting our x's to the right, numbers to the left. So if we look at this, starting from the left, 20 minus 34 is negative 14. So we're done with that. These cancel out. 34 minus 34, that cancels out. And then finally, 15x minus 8x is going to give us 7x. Divide by 7. That cancels, and we get x equals negative 14 divided by 7 is negative 2. So we're good with that. And once again, we could plug that back in there if we wanted to make sure that we got the right answer. But we're looking good right now. So Okay, sorry about the dogs. I'm at home right now. So, moving to this next one, what we're going to do is we're going to move the decimals. And that is, when we see these decimals, we can work with decimals. And I think most people are fairly comfortable with working with decimals. But what we can do is we can multiply everything by 10. If we multiply things by 10, we move the decimal to the right one. So just multiplying everything here by 10, you'll notice what we get is this. 10 times 2.1 is 21x. 10 times 45.2 is 452. 10 times 3.2 is 32. And 10 times negative 8.4 is negative 84x. So that's what we're looking at right now. So what we want to do is we want to get all our x's on one side and our numbers on the other, because I want to keep my x's positive. I'm going to move my x to the left, which means I'm moving my number to the right. So that means we have to subtract 452 from both sides, and we're going to add 84x. So looking at that, 21 plus 84 is going to be 105x. 452 cancels. Over here, if we have 32 minus 452, that's going to be negative 420. And our x's cancel there. So finally divide by 105. So we're dividing to get rid of that, because 105x is 105 times x. So we divide that by 105, and we get x equals negative 4. So we can get rid of the fractions, as we saw up here, by multiplying through by the lowest common denominator. We can get rid of the decimals by multiplying by 10. Now, looking at this next problem here, what we want to do is, first thing we want to do is get rid of the parentheses, which is kind of a natural thing to do, so we're going to use distribution. So 8 times 3x is 24x. 8 times our 2 is plus 16. That equals 30. Now we're going to subtract 16, because we're getting the x's alone, so we only have x's on the left. Move the 16 over by subtraction. These cancel out, so we get 24x. 30 minus 16 is going to give us 14. Divide by 24. So we get x equals 14 24ths, which can simplify to 7 twelfths. And that's the answer we're looking for right there. So moving on to this next one here, we need to get the numbers on one side and the x's on the other. So I'm going to move my x's to the left side. So subtracting an x from both sides, we'll notice that we get cancellation here. So we get negative 23 equals negative 23. Now, as soon as the variables are gone, one of two things is the case. We can get something that's always true, or we can get something that's never true. So right here, because negative 23 equals negative 23, what that tells us is we can put any number we want in for x, and that's going to give us a true statement. That is, negative 23 plus 1 is the same thing as 1 minus 23. Negative 23 plus 5 is the same thing as 5 minus 23. That is, x can be anything. So the solution to this is all real numbers. Okay, so notice the variables left, we got something that's a true statement. Does negative 23 equal negative 23? The answer is yes. It's a true statement, so it's all real numbers. Now looking at number 17 right here, if we move the variables over, I'm going to add t to both sides. So plus t plus t. Once again, the t's cancel. But notice what we get. 17 equals 68. Does 17 equal 68? Well, the obvious answer here is no, which means that it doesn't matter what you put in for t. You're never going to get this thing to be equal. That is, there's no value of t that can actually make this equation true. Because there's no value of t that makes this equation true, the answer to this is no solution. So kind of recapping, if the variables go away, if we get a true statement, all real numbers, that is, we can put any number in there. If the variables go away, we get something that's false, that is, 17 does not equal 68, then there are no solutions. Now moving on to the last two problems here. First thing we want to do in both of these problems is get rid of the parentheses. So what we want to do is distribute. Now, the one thing I'm drawing your attention to here is in this first equation right here, this negative x is a negative 1. So we have our 5r, but when we do our distribution, we're multiplying the negative 1 times the 2r, giving us negative 2r, the negative 1 times the 8, giving us a negative 8, and that equals 16. So we have to see that as a negative 1, and we need to distribute to both terms in the parentheses. Now, simplifying this by combining like terms, our 5r minus 2r is 3r, minus 8 equals 16. Adding 8 to both sides, we get 3r equals 24. And then dividing by 3, we get r equals 8. That's the solution. We can plug it back in and see that we're going to get a true statement up there. Okay. So, moving on to this last one, same thing. We need to get rid of all our parentheses, so we want to do our distribution first. So here, our 11 is hanging out there. This is a negative 4. We need to distribute into here and here. So negative 4 times x, negative 4x. Negative 4 times a positive 1 is negative 4. And then our minus 3 carries down. On the right side, we still have our 11. We're going to distribute the 2 into here and here. And because we have plus 2, it's positive. So 2 times 4 is 8. 2 times negative 2 is negative 4x. And then we have our minus 16. Now we want to combine like terms here. And notice we have 11 minus 4 minus 7. So 11, excuse me, not minus 7. Minus 4 minus 3, that is a negative 7. So 11 minus 7 is going to give us 4 minus 4x. On this side, we have 11 plus 8, which is 19, minus 16 is 3, so I have 3 minus 4x. Now we need to get our variables on one side, so I'm going to go ahead and add 4x to both sides. Cancellation here, and notice the variables go away. So one of two things is true. It's either all real numbers or no solutions. And here, because 4 does not equal 3, it's no solutions. If we got something that's true here, it'd be all real numbers, but since we didn't, that is what we're getting. So that's second part of using principles together. See you next time.